Hello everyone. Let us continue with the relational model. In the previous video, we already discussed about the various relational model concepts. Now, in this video, let us look into the relational model constraints. Constraints on relational database model. An integrity constraint is a condition that is specified in a database schema and it restricts the data that can be stored in an instance of the database. So the data that satisfies the conditions are allowed to be stored in the database. So this integrity constraint is nothing but a condition that is specified on the schema and it restricts the data entry into the database. So if the database instance satisfies all the constraints or all the conditions specified on the schema, then it is a legal instance, else it is an illegal instance. Okay. The referential integrity constraints can be referred to as a conditions which must be present for a valid relation. Okay, so these constraints we are going to apply that one onto the relations. Let us look into some examples for the constraints that we are going to apply on a relation. The account balance cannot be null. So the condition is the account balance, that field should always have some values. It cannot be null. Another example, no two accounts can have the same account number. That is, the account number should always have some distinct values. The hourly salary of an employee must be at least 1000 rupees per hour. So the salary field should always have the values greater than 1000. Okay, let us look into some types of integrity constraints. We'll have three types: domain integrity constraint, key constraints, and referential integrity constraint. Now let us look into the first type of constraint, that is the domain integrity constraints. These domain integrity constraints are the most elementary form of integrity constraints and they can be tested easily by the system whenever a new data item is entered into the database. Okay, as we know, this domain is nothing but a set of possible values associated with every attribute, and this domain must contain atomic values. That means it is not allowing this composite and multi-valued attributes. In the given example, this name is a composite attribute and this phone is a multi-value attribute, and so it is violating the domain constraint. So the condition here is that this every domain must contain atomic values, and that condition is violating since this phone is a multi-valued attribute. Okay, so the condition that we are going to apply on to the domain can be called as the domain constraints. This domain integrity means the definition of valid set of values for an attribute. So this attribute will be holding only valid values which satisfies that particular constraint. Okay. By declaring an attribute to be of a particular domain, that one can also be act as a constraint on the values that it can take. For example, if a particular attribute can be defined as an integer, then it can take only integer values. Okay, that one can also act as a domain constraint. Okay, the check clause in SQL permits the domain to be restricted. For example, the domain values, for example, the age should be greater than or equal to 18. So we are restricting the domain with the values greater than 18. The age should be greater than 18. Only such values will be allowed to be in the domain of age. So we are specifying a predicate, we are specifying a condition that must be satisfied while entering the data. Okay, so by means of this check clause, we can insist this domain constraint. Now let us look into the second type of constraint, that is the key constraint. This key constraints can also be called as uniqueness constraints because it ensures that every tuple in the relation should be unique. A key constraint is a statement that a certain minimal subset of the fields of a relation is a unique identifier for a tuple. That means a minimal set of attributes can be used as a unique identifier for a tuple in the relation. So that is the key constraint, and we'll be having four types of key constraints: primary key constraints, unique key constraints, foreign key constraints, and not null constraints. As you know, the primary key attributes are used for uniquely identifying a tuple in the relation. So the conditions that should satisfy by the primary key attributes are it should not allow null values and it should contain unique values. It should contain distinct values. So these are the two constraints that should satisfy by the primary key attributes. That the column or the attribute that is defined by the unique constraint must have a unique value. So the condition here is that the column defined by the unique constraint accept only the unique value. It should contain distinct values. That the third type is not null constraints. It won't allow the null values for that particular attribute. So if a particular attribute is defined by not null, then the domain won't accept the null values. And the last type of constraint in the key constraint is foreign key constraint, which is used for enforcing the referential integrity between the relations in the database. Now let us discuss about the third type of constraint, that is the referential integrity constraint. This constraint is specified between two relations or tables. This constraint is used for maintaining the consistency among the tuples in two relations. So the condition or the constraints to be applied on the foreign key is that the foreign key value must match the primary key value of the referenced relation. The foreign key of the referencing relation should match with the primary key of the referenced relation. That is the first constraint. Or the foreign key value must be null. That is the second constraint. So it can be either null value or it should match with the primary key of the referenced relation. So these are the two constraints that should satisfy by the foreign key. So that constraints can be called as referential integrity constraints. So this referential integrity also includes the rules that dictate what types of data manipulation are allowed on referenced values and how these actions affect the dependence values. So if the foreign key is getting updated or deleted, what happens to the corresponding entry in the parent table? Or if a value in the parent table gets updated or deleted, what happens to the corresponding entry in the related table? So it also refers to the types of data manipulation that are allowed on the referenced values and how these actions affect the dependent values. The various referential integrity rules are: the first one is restrict. It disallows the update or deletion of referenced data. That is, we can't delete a record from a primary table if the matching records are there in the related table. We can't update or delete a referenced data if its matching data is there in the related table. Okay, the next rule is when the referenced data is updated or deleted, all the associated dependent data can be either set to null or we can set it to default. We can set it to a default value. So that the two rules, set it to null and set it to default value. So when the referenced data is updated or deleted, all the associated dependent data can be set to either to null value or it can be set to a default value. And another rule is on delete cascade. When referenced data is updated, all the associated dependent data is correspondingly updated. So when a referenced row is deleted, all its associated dependent rows are deleted. Okay, so when a reference data is updated, the dependent data can also getting updated. When a referenced row is deleted, the associated dependent row also gets deleted. That can be called as cascade. Simultaneously, both the updations or deletions are performing in both the parent table as well as in the related table. So these are the various rules, various referential integrity rules. Let us discuss the same point with an example. Here we are considering two relations, student branch and student course. The student branch consists of three attributes: student ID, name and branch. Similarly, the student course consists of three attributes: student ID, course and duration. Okay, the student ID is, the domain of the student ID is same in the both the relations. Okay, the first rule says that we cannot delete any of the rows in the student branch table that are visible since all the student branch are in use in the student course relation. By looking into the two relations, we can say that each table will be having 5 tuples with the same student ID. So we cannot delete any of the rows from the parent table if they are there in the related table. Okay, so we cannot delete it from the student branch since the same domain is there in the related table called student course. The second rule is we cannot change any of the student ID in the student branch relation since all the student ID are in the use in the student course relation. The first rule is we cannot delete any of the rows from the parent table. Second rule states that we cannot update the values in the parent table because they are using by the related table. The third rule states that the values that enter in the student ID field of the student course relation must be in the student ID field in the student branch relation. That is, the related table should hold the values that should be there in the parent table. Okay, so the domain of the student ID in the related table, the values should be there in the parent table. We cannot have the values other than in the parent table. We can enter a null value in the student course relation if the records are unrelated. Let us consider one more example. Here we are having two tables. The first table will be having EID, name and department number as the attributes, and the second table will be having the attributes as the department number and the place. The department number of the first relation is the foreign key and the department number in the second relation is the primary key. Okay. Department number is equal to 22 in the foreign key of the first table is not allowed because its parent table, this value is not there. This 22 is not there in the parent table. So there occurs a referential integrity constraint violation. So in this video, we discussed about the relational data model constraints. We discussed the three type of constraints, the domain constraint, key constraints, and the referential integrity constraints. Thank you.